data pipeline is a series of data processing steps, and each step delivers an output to the an output that is input to the next step, and it continues until the pipeline is complete. In some cases, some steps may be parallel, but just ignore it for now. So we move the data through a pipeline and get the result at the end. Data pipelines consist of three key elements, as we know: resource, processing step or steps, and the destination. Sometimes in some articles they call the destination sink. And the data pipeline enable data from, for example, from application to data warehouse, from a data lake to analytic system or database. For example, in the business I work, e-health, I need at the end of the day give a sum of performance of doctors, for example, message to them, or they need to see it on the application that they use. So I should prepare data for them, is one of the examples. Or maybe when a doctor wants to prescribe something, it's search a drug or a service or a brand of a medicine. So it needs a recommender system. Also, data should be prepared for this recommender system. Also, it needs, for example, a pipeline. And the most important part of, I think, every business is the finance. Each month, I have to have data performance of each province in country for managers. So for these three examples are what I work with. For the first example, every 10 minutes my data should be ready. For the third example, every month my data should be ready. And when we see tools that do this for us, for example, data stage in IBM or ODI in Oracle, when we use these tools graphically are like a pipeline. So data starts from here, goes step by step, and then is ready and is a destination. So what I'm trying to emphasize is that that really it's a pipeline, even in the tools. Maybe you are familiar with this. But for example, in Oracle, we have a very complicated tool. Its name is ODI. In ODI, first we make a map. In this map, we prepare the data. Then package of this mappings just make a package. Then we put the package together, and data comes from package to package, and then at the end is ready. These packages can be sequential or parallel. And then at the end, we have a schedule. We schedule that this fellow run as we wish. What I'm trying to say is that this map package schedule is everywhere, but if you ask me, is a little bit old. Also in new tools like NiFi, you might heard of NiFi, Apache NiFi. With NiFi we can move data from source to destination, from several source to destination. Even NiFi, when you see graphical part of NiFi, we see the pipeline. What happens in real world is that the business have some requirement. Because of this requirement in my business, in the business I work in, can be, for example, a medical intelligence dashboard. A dashboard which shows medically what is happening in e-prescription world. Or, for example, also maybe we want to monitor hospitals, or managers in hospitals wants to just check the performance of people who works in a hospital. So because of these requirements, I have to implement, I have to develop a pipeline. So this pipeline can be batch or streaming. Today we are going to talk about streaming. But what happened in the real world is that for implementing, for building this pipeline, we need a stack of tools. This stack of tools is the third layer, the last layer, and DevOps people actually work on this part because of importance of some tools like Spark or Kafka. I little bit talk about Spark and Kafka as important tools to build the SME pipeline, and that I want to talk about. So it is what's happening in the real world. You have a requirement, you have to build a pipeline. This pipeline is on data stack. A big data pipeline is a pipeline can handle big data. But you now is 220. We all know what is a big data. Big data is when we call data big data when there is a dramatical change in volume, variety, and velocity of data. So today also we don't want to talk about just pipeline. We want to talk about the big data pipeline because of the velocity of the data. Because of the velocity of a big data, it's very appealing for streaming. Also, because of the volume of data, this pipeline that I'm going to explain should be scalable, of course, and it should be scalable. I will explain it more later at its place. And also because of variety of big data, the pipeline I'm going to build here, I'm going to explain how to build, should handle many different types of formats and data, extraction, unstructured, and semi-structured. Okay, so I talked about data pipeline, big data pipeline, and now streaming data pipeline. Streaming data pipeline follows data continuously from source to destination as it creates. And I think it is the main point here. And if you are not familiar with streaming data pipeline, or for example, you are not a data engineer, or you are generally working in data world, I should tell you that if we consider data an ocean, if you just take bucket of data with different sizes, it's a batch processing. And if you have a pipeline, if you have a water pipe that just moves the data from the ocean to wherever you want, it can be a streaming data pipeline. I think it's a good example, a general and good example for that. Let me walk through the history here. That what happens a few years ago and still now in some businesses is that we separate analytical part of business to night jobs. For example, if I want to prepare data, I say, okay, is your transaction that happens daily on systems, and okay, I put it here, I put it aside, and now I want to build some dashboard, do some prediction. So I have to prepare data. What I do at night, as a quiet time, I bring the data and prepare it for the next day. So, like 10 years ago until now, what we do in most businesses is that we prepare data overnight. And what happens? Businesses have accepted this. Okay, I have a data, but it's, for example, 24 hours late. But little by little, and we call it ETL, ETL data for in fact analysis. It has some drawbacks, and if you ask me, the most important, in fact, drawback is that it needs a schema, it needs a lot of resources, and also it's slow, and you have to monitor it constantly. If one night, 2 nights, God forbid, more than 2 nights, your data is not prepared, your dashboards, your reports are late, and it is not, in fact, good for, at least for this decision making. Little by little, but batch of data shrink, volume of data grew, and demand for fault tolerance systems grow. So also at the same time, distributed storage architecture blossom with Hadoop and Cassandra and the other technologies. So because of this demand for more timely data, and then Spark, we changed, in fact, we changed how we look at data in a big way. Because Spark presented a consistent API, it could run on a cluster or a standalone. So, as a developer, you had you could run your code on a small scale and then move it to a cluster, because Spark had this ability. So because of all these changes in a few years, demand for to building real-time data increase, and so we moved from we are in fact moving from batch processing to stream processing. As I told you, this presentation has two focus: when and how. If I want to answer the question when, as I mentioned already, if your business need timely data, you should go for a streaming, for a streaming. And also, if you have a massive unbounded data set that increase a lot, you should consider streaming, which, as we know, in many businesses now it's so common. And also, if you want to process data as it arrives, you don't want to store data. You want to process it along the way. When data is moving, you want to process it. You don't want to store it first and then process it. Then it is when we go for streaming. Something that I should explain here. I have two main examples. Is one of doing streaming on logs and in e-prescription. Before I explain these examples, let me have another general example. When you can think of a batch processing as producing a movie. A script is ready and is definite. Based on it, you create a movie. And you can change it. You can change the script when it's done. You can add. If you want to change it, you have to do it from the beginning. It's what's happening is in batch processing. If somebody is here who works works as a BI engineer, as a data analyst, knows this part very well. But streaming processing is like an episodic show. Yes, we know the story, but during the episodes we can change it little by little. It is what happens when you are, in fact, making a streaming pipeline. The first example, which we are doing in e-prescription, is logs. When you have a complex business like e-prescription, which is based on insurance, health insurance, you have to use a microservice-based application. Otherwise, you are in big trouble. So when you have a microservice-based applications, these services talk together, communicate together, and if something, and maybe if one or two of these services fail, we will have a complicated situation. Also, when you want to find the error, find the bug, find the failure, you have to survey whole request of a flow. So for that, for these reasons and more reasons that I didn't mention here, you have to have meaningful logs. These logs help you to track errors. Okay, how you track errors? When you want to track errors, you do it by monitoring, but visualizing, and also with monitoring and visualizing, you can solving the issues. But you have many small services. They talk together. All of them produce logs, and it's become complicated. So you go for, as we know, to predict errors, because when you predict errors, you can filter your monitoring. You can have a better visualization, and also you will be ready for solving the issues. As we know, huge data, complex pattern, we go for ML, machine learning. So it is what we need in our logs, ML data streaming. So one of our cases that we needed to go for streaming data was surveying and, in fact, predicting and solving the problems happens in our system with what we do on our logs. The other example is fraud prevention. When it comes to e-prescription, just imagine this. So somebody goes to doctor. The doctor prescribes something for him or her, and the moment he prescribes and click, okay, it's over, it's finished. Insurance guidelines are working on this prescription, and at least they calculate the price. They do a lot of things, but at least they calculate the price. For this, we will have JSON, big JSON of this calculation and the other actions that is done, and also we prevent some fraud, of course. For example, if you are a pregnant woman, some drugs shouldn't be prescribed for you, or your insurance doesn't cover some services. They should be eliminated from your prescription, or they should be, the insurance part should become zero. So this fraud detection, that at the moment you should do some actions on the, for example, prescription. You need a data streaming because you need the data at the same time. Also, we can use for fraud detection, but we should have a better reason for fraud detection to use streaming. I will explain it later, but for fraud prevention, we need streaming data. And the second part that I told you that I want to focus on is how we should have a streaming data pipeline. It is blueprint of streaming data architecture. We have like 5 tier: collection, message queue, analysis tier, in-memory data, store, and data access. But this long-term storage is optional. I will talk about it later. And as I told you, because there are 2 important. Okay. If you ask me what are which one are more important, I tell you that message queuing and analysis tier are more important. They are heart of data streaming. So because they are important, and the importance comes from 2 very good tools. I will explain about Kafka and Spark here a little more. So the rest of presentation, I'm going to talk about these tiers. And also when I reach to queuing, I will talk a little bit about Kafka. Of course, it's more complicated than that, but I just simplified, and also I talk about Spark as a very good streaming process tool. Let me go through the architecture by example. First of all, collection tier. When a doctor prescribes a treatment or some medication, it is collected by some services. I call them ERX services, but it is not a general name, by some services. All over the country, doctors write prescription, and when they collecting data and answer of data is not in the same server. They are across the country. So I need a message queuing. Also, we are sure that there are some analysis on prescription. One of them is calculating the price. In a long-term storage tier, when I don't want to talk about this part here, but just imagine that when a doctor prescribes something for you, maybe it's based on the history that you have. So in some cases, maybe you need to show some history to the doctor. And in-memory data store tier, the prescription that are mere second old, they are not too old. They may help you to, for example, build a recommender system. Think of it as a Google search. So when you search something, your recent history show up. So maybe it is what you have for doctors. So you need in-memory data store for recent data. I explain it more. And also data access. Of course, what happens in the system should be available for the system clients, doctors, patients, hospital managers, and some people. So I just try to go through an example for this architecture to clarify it better. In fact, when we want to build something from scratch, we need some definition. Definition of the real-time data is that designing a system that delivers the information a client requests at the moment it needed. It shouldn't be necessarily at time. It should be prepared when a client requests for it. So it is a definition of a real-time data. So if a client at data is ready, we call it the real-time data. Maybe it's 3 minutes later, 4 minutes later, or at the same moment. The collection tier as a first tier it's when the data enters to the pipeline, and it's very important that how it's a pattern of this data entry. It's request response. That you search something on your browser. It's very simple. You request something and then you will have a response. Or publish subscribe pattern. Internet data is publish subscribe pattern. Like say YouTube, that publish something, and whenever you want, you go and have a data. But one-way pattern, when the data is generated, but you don't need a response or acknowledge or anything. Request acknowledge is not a response, but just you want to tell that this happened. For example, in marketing, each click that the user do on the website can just acknowledged by system, by platform, by a system, and then you can see, okay, what is propensity of this user to buy something. You can, for example, calculate that. And stream pattern is that when your data comes to your pipeline from another stream. So you have another stream. This data comes to your pipeline from another stream. We call it a stream pattern. So this collection tier can be one of these, and based on one of each one, and we may implement this part. While you are designing your collection tier, you have to take care of 3 points: scalability, fault tolerance, and also logging. I don't talk about them, but if you have questions, we will come back to them for more detail. Message queuing tier is the second tier. In a message queuing is line of messages in order to communicate between two systems. So your data comes, your data is ready. You don't go to the analysis tier. You put it in a queue, then analyze it or process or do some process on it. Why we do this? Why we put the data in a queue and let's say one by one we do the analysis? It's because that we don't want to collection tier and analysis tier effect on each other. We don't want the effect on each other. We want to, the word is decouple them. For example, maybe your analysis tier is disconnected, or is slow, or simply is slow. So what will happen? Your data gathers here a lot, and then maybe a crash happens. So we want to decouple our services, decouple our tires, decouple our applications. So we use message queuing. Core concept of message queuing is like this: so data produced, it stays on a broker, on a server, on a node, in a queue, and then it's consumed. It seems so simple, but not really. It is not that simple, and the devil is in the details. But let's talk about it via Kafka. So if I want to summarize why I have to use message queuing in my pipeline, is I want to decouple producer and consumer. Producer as a collection tier and consumer as a analysis tier. Producer and consumer are decoupled. Slow consumer, because most of the time the consumer is slower than producer. So this slow consumer doesn't affect on produce. And also you can change, for example, increase consumer, increase producer, decrease producer, or do some changes on consumer without affecting on this layer. Also, if a consumer failed because they are in the different nodes all over the world, all over the country, it doesn't affect the system. And okay, if I change the architecture to the collection tier goes to a broker and the analyst tier use. There are many points that you should consider when you want design a pipeline. In fact, choose and design this. Choose or design this message queuing tier. But one of the important ones is how your message, type of message. What is your type of message delivery? For example, it is at most once the message may get lost, but it never be read by the consumer. At least once a message will never be lost, but it may be read by the consumer. Or exactly once a message never lost and read by the consumer once and only once. You may say, of course, I want always exactly once. The message doesn't get lost, and also consumer just once read it. But it is not the case in some businesses, and also because of the complexity of it, I think sometimes at most once or at least once are even better. For example, in marketing, sometimes if a message gets lost, no problem. There are the other messages that can make the same point. So, if you want to choose which delivery type that you want to choose, maybe you should answer some question. But it all depends on the business you're working. There are some questions that you can reply for that. For example, maybe you say that, okay, I don't want the message queuing part, so you should you should answer this question. What would be the impact to the fraud detection, for example, your system or fraud detection business, if the communication between collection tier and analysis tier interrupt for a period of time? What will happen if this happens? So if your business can tolerate this, nothing happened to your business, so it's okay, you shouldn't have a message queuing. But in this business that you are in the, e-health business, e-prescription business, that you are at least you're calculating the price, you can't afford it. Your messages shouldn't be lost. Or more important, how many days of worth of data can your system tolerate losing? For example, if you had the ad system, you can say, okay, for 1 or 2 days, the ad doesn't work, or the ad is not precise, or does the target of the ad has some ambiguity. It's okay. But when you are, for example, working in core banking, it would be disaster. Also, the next question that you should reply, that do your system need historical data? And I think, for example, if your system is fraud detection, you need history, because it's based on a history that a person and a process has. And also the last question, what type of message delivery semantic does your system need? You should choose one of them as an answer. So for message queuing part, if you want to be clear to choose it or not, or when you choose it, choose which tool or how you deal with it, you have to answer some question. Some more important ones are these. And Kafka. Kafka is what's usually used in big companies for message queuing. It has a 3-part: producer, broker, and consumer. And when producer produce some data, some log, some message, in the Kafka we call it message, produce some message, you have to know which topic. Topic is like table, you know. So you have to know which topic. So you have a topic, you write your data in topic, and the consumer use them whenever it needs. And also once you write it in the topic, consumer can read it multiple times. So your topic is getting big and big and big, and we know when the data become big and big, what we do, we use a partition. So also we have partitioning in Kafka. You partition your data and do it parallelly, or and because Kafka is distributed, open source, and distributed is also escalated. And then as a tier, as a more important, my favorite part, as a tier, for explaining analysis tier, let me compare it to the in fact traditional analysis tier that in batch processing. For example, you want to determine which link is broken. It is what you want to find out. You gather the data from your website, for example, load the data into a DBMS as your database, and then execute a query and determine if the link is broken or article is trending. It is the business. This is the requirement that you want to find the data. Then you take action. Then afterwards, repeat it if you want to say, okay, so after 10 minutes, 20 minutes, X minutes, again you run the query. It is what happening in traditional form. But in streaming analysis is to collect the stream of data, you start a query, and query works on this in fact stream of data. And okay, so because I have just 5 minutes, it is what I explained just in picture. Spark, it is what does this for us. And as a very important tool, I'm going to explain it a little bit. You might know that, in fact, Spark developed in Berkeley lab in 2009. In 2000, then become open source. In 2013, was given to the Apache project, and in 2014 became a top-level project. And now, and until now, this development is going on. Okay, so Spark is based on RDDs. RDDs just are some sort of data structure that Spark work on them. They are spread over the clusters. RDDs can be made from a text file, from SQL databases, from NoSQL databases, from HDFS, and all MapReduce function can be done, can be performed on them. Also joining, filtering, all can be done on them. And also all of these actions in Spark is done in memory. And this RDD helps that to hide complexity of performance and what Spark does from the user. And here just I'm explaining it. Okay, so soon. Okay, so driver and executor are in fact main of core of Spark. What happens is that the program execute, a Spark context is built. It's like an orchestrator. This orchestrator just have a schedule, just build a physical plan. This physical plan decide which task in which order should be executed, and these executors are done in each work node, and this work node do the computation, and the result will come back to the driver. It is core of Spark. It is in fact a Spark core, and on this core there are some important libraries like Spark SQL, Spark Streaming, ML, and GraphX. Spark Streaming is what we use as a tool in our pipeline. And for Spark Streaming, make an unbounded table. From our data. For example, every 5 seconds, every n second n is configured by you. Just a table is built, and then Spark SQL is run in this table. Also, there are an old one, DS streaming. That is, it makes RDD of micro batches. So, for example, so data is coming. So every 5 seconds, you make an RDD. So you have a stream of RDDs, RDD, a stream of RDD. So you have a stream of them. You do some action on them. So it's work of developer is more, because the developer should write some UFD on them. But in the previous one, a structured data streaming, you build a table. So for this table, you can use SQL, Spark SQL. You can use Spark SQL. So it's much easier. So it also is obsolete because people use it less and less. In-memory data store is okay. So your data is processed. Your data is processed. When your data is processed, what happens after? You analyze data and discard the data, you analyze the data and push it to, for example, to another streaming platform, or push it to the same streaming platform, analyze data and store it in a database, analyze data and use it for offline access. It is based on each decision your in-memory data is stored should be designed. And also the last one, which I'm not going to explain because the time is over, but if you have questions, we will talk about it. Data access tier is when your data is ready and you want, and a client, a user, a dashboard, an application needs data. You need this data access tier for, in fact, providing data to the client, for example. Okay, thank you. Questions? I told it so fast, so if you have a question or details, I'm ready to answer.
Thank you very much for a great talk. So you mentioned the Apache NiFi, right? At the beginning of the talk.
Yes, yes.
And you mentioned the Spark streaming.
Yeah.
So what is the technology that you actually use? Because as far as I know, technologies are quite
I use a Spark. We use, in fact, a Spark, yes. But NiFi, well, because there are many shiny tools, you know, and they are open source. So, but NiFi is a good example that it's actually an ETL tools, because engineers who ETL data for years, they don't want to change. So that's why we have SQL Spark. Okay. So also NiFi give them the same sense. So that's good. No, but I use the Spark. Yeah, of course. Thank you.